cones. So let's go over some of the vocab that will go along with these. So a pyramid is a polyhedron in which you only have one base. Yesterday we had two bases, they were parallel. This one you only have one base. All the other lateral faces are what shape? Triangles. So yesterday the lateral faces were rectangles. Today they will be triangles. So if you want to find the surface area without the formula, you would find the area of the hexagon in this case, and then you would add on 6 triangles. Okay, but we're going to learn a formula. So the base, remember, can be any polygon. It could be a triangle, it could be a square, it could be a rectangle, it could be a dodecagon. Which means we're going to have to find big B, the area of the base. We're going to have to use the formulas that we learned in chapter 10. Lateral faces, again, are triangles. Now there are multiple heights, air quotes, heights, of the pyramid. If you look over here, the height itself, or the altitude, is of course a perpendicular segment connecting the vertex to the base. That's what this one will be. The altitude is a perpendicular segment that joins the planes of the bases. This is also referred to as the height, which will be capital H. We're going to notice in the formulas today, we don't have capital H in our formulas. Okay? Because if you think about it, we have to find the area of this triangle. And this height is not the height of the triangle. The height of the triangle would be like slanted. If I were to take this face and pull it off, it would be the height here. This is called the slant height. Probably on my next slide. The variable for that is L. So, first I have a regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles, which just tells you that all 6 of the triangles will be the same size. This is what I was talking about. The slant height, L, is the length of the altitude of a lateral face. It's called a slant height because it's going to be your slanted height. The height of the slanted surface. We abbreviate that with L. We don't use S because S is usually the side of a polygon. So that's why they use L. Cones, similar to a pyramid, but the base is obviously always a circle. So a cone is pointed like a pyramid, but its base is always a circle. So kind of like the cylinder, but it also will be kind of easy since we only have a couple of variables. You can see we'll have the radius, we'll have the height, and then we still will have a slant height, which will be the height of the side of the cone if you were to unpeel it. So we have in a right cone, the altitude is a perpendicular segment going from the center to the vertex. And the slant height will be the distance from the vertex to a point on the circle, on the edge. So a couple examples just asking us to name the figure. Again, we name a pyramid by its base, by the shape of its base. We will use our eyes to judge what we think they are. So who thinks they could name this shape? This looks to be a square to me, so this would be a square pyramid. If you think it looks like a rectangle, then you could put rectangular pyramid. I would accept either answer, since it doesn't tell you it's definitely a square. What would the next one be? A hexagon, so a hexagonal prism, or pyramid, pardon me. Next one is a pentagon. So we'll say a pentagonal or a pentagonal pyramid. Again, if you just write pentagon pyramid, I won't mark off, but it's proper to put the AL at the end. And then the last one is a cone. It's technically a right cone, but if you just put cone, that's fine. We'll learn that there's still oblique cones, and an oblique cone would look like this, like be kind of like slanted. Just like we had oblique prisms yesterday and cylinders where they were slanted. All right, so now to our formulas. Lateral area and surface area of both of them. Remember that still P, just like yesterday, is the perimeter of the base. So whatever the shape of the base is, you have to find the perimeter. L is our slanted height. which sometimes we'll have to use Pythagorean theorem to find, okay? And B is still the area of the base. So lateral area will be equal to 1/2 times P times L. And my L is not really cursive like it should be. So that's the perimeter of the base times the slant height. Surface area is to take the lateral area, 1/2 PL, and add on. This time it's only plus B. Why is it not plus 2B? No? There's only one base in a pyramid instead of having two. Okay? Cone is going to be basically the same formula, except that we know the perimeter of a circle is the circumference, so that's 2 pi r. And we also know the base is a circle, so that's always going to be pi r squared. So the lateral area will be pi RL. And that would be 1/2 times 2 pi r. The 2 and the half would cancel out to just leave you with pi RL. And then for the surface area, we're going to take this and add on a circle, pi r squared. So pi RL plus pi r squared. And make sure these L's maybe look a little bit more cursive-y, not like ones. So if you want, you could add those to your formula sheet too while we're here. And you can see now that the only one we have not learned is the sphere. On the back, you'll see we have volume formulas. That's what we'll be getting to next week, is the volume of the figures. All right, now again, always make sure you read directions, because sometimes they ask you for lateral and surface. Sometimes they just ask you for surface. So if they just ask you for surface area, you don't have to find both. You can just use the surface area formula. So our first one says, find the surface area of the square pyramid. So we'll write out our formula, which is 1/2 PL plus B. So again, P is the perimeter of the base. What would the perimeter of the base be? $32. 8 times 4, because it's a square, or 8 plus 8 plus 8 plus 8. Give me 32. So that goes in here. L, remember, is your slanted height, which they did give us. So this is L, 7.2. Plus, what will the area of the base be? $64. 8 times 8. 64. And then you can type that whole thing in your calculator, or you can do it piece by piece if you prefer. This will get me 115.2. Adding 64 to that, we'll get 179.2. And again, this is still square inches, because we're looking at just the surfaces. Okay, number 2 gets a little bit harder. And that's going to be because we don't know the slant height. And the base is a regular polygon, which means we're going to have to use like 1/2 ANS. So let's start off with the formula. What would the perimeter of the base be? Marquise? 240. One side like this, 40, and we have 6 of them. Now, for L, we don't know the slant height. So we are going to have to find the slant height using the actual height, the apothem, and you can create like a right triangle, and I'll redraw that triangle out here. So the actual height is 70. The apothem, they tell me, is 34.6. And then I can use Pythagorean theorem to find out what the slant height is. So let's go ahead and just call that L. And so we'll do our Pythagorean theorem. Now, if you want a faster way to do this in your calculator, so that you don't have to square them, then subtract them, then square root them, you can leave them in exponential form and subtract them. So you can subtract the 34.6, and if you are getting confused by what I'm about to do, just ignore me, do regular Pythagorean theorem. But if you want, you can do this in your head normally. L squared equals 70 squared minus 34.6 squared, and then square root both sides. So you can just type this in your calculator. Then if you're not following, ignore me. But some of you will catch on, and then whenever you do Pythagorean theorem, anytime you're looking for the leg, you just have to take the square root of c squared minus, for example, a squared. And then that way you don't have to get a bunch of decimals and write them out every time. How many of you are following what I just said? All right, now we shouldn't round that. Oh, shoot, I did this wrong. Why did I plug 70 in for C? It's B. Oh my gosh, I'm so sorry. Step in a little earlier next time, guys.
Well, you were showing us something new. I thought
Well, that will work whenever you have to find A or B. I'm sorry.
I thought it was like you meant to do that.
No.
But then I was trying to figure it out.
No, I'm sorry. A and B are your legs. C is our unknown. So for this one, we could still do this. And then we'll just type in the square root of 34.6 squared plus 70 squared. So that we don't have to, again, square each of the numbers and then add them. So this is still a shortcut you can use. So we'll get that L is approximately 78.08, which we can leave in our calculator so we don't have to round anything. And then we still need to find out what B is. B is the area of the base, which is a hexagon. So we'll have 1/2 A N S. And this one isn't really bad because they give us the apothem. And they give us the side length and they give us the number of sides. So we just have to substitute it. Our apothem was given to us. That's this little dashed line, 34.6. The number of sides was a hexagon, right? So we had 6 sides. And one side length was 40. Multiply all of that together, and we should get 4,152 for big B. And now we just have to plug this all in. Now I'm going to leave that 78.08 in my calculator so that I'm not rounding it. You could store it too if you want. But I'm going to multiply that by 240 and times 1/2. And then I'm going to add my 4,152 to that. And so we should get 13,522. They didn't tell me what to round to, so you could just do nearest whole number or nearest tenth, whatever you're feeling. And this would be square centimeters. Okay. Next one is a cone. And cones are pretty easy because you don't have to find big B. I mean, you do, but it's in the formula. So we have pi RL plus pi r squared. So our radius is given to us, that's 15. Is 25 L or H? It's L. If it's labeled next to the slanted part, then that's what it is. If they wanted it to be this line, they would draw an arrow or they would put it inside the cone. So this is really just plugging in. Simple fun. We'll leave it in terms of pi. since they both have pi's in them, we can then add them together, and we'll get 600 pi square centimeters. Now the next cone isn't as easy because they don't give us the slant height. So in the next one, they do give us the diameter this time is 12, so that means the radius is 6. But 15, see how it's pointing to the actual height? This is capital H, which is not in our formula. So again, we're going to have to find L using our Pythagorean theorem. So kind of creating a right triangle here. If this is 15 and this is 6, we can do the Pythagorean theorem to find L. So let's do this right this time, Mrs. Bennett. 16 squared plus 6 squared plus 15 squared equals L squared. Our hypotenuse is the unknown. And then, again, if you want to use your shortcut, so that you don't have to square them and add them, you can just square root both sides, and then type the square root of 6 squared plus 15 squared. Again, we're not going to want to round this. Oh, I guess we are going to have to round something at the end of this problem. But it tells us to round to the nearest whole number, which means you are using the pi key, or 3.1 form. So anytime it says round, that means plug in or evaluate using pi. So we'll have pi times our radius times our slant height plus pi times 6 squared. So I'm just going to take that answer I had, I'm going to multiply it by 6 and by pi. I'm going to hit enter. And then I'll add on, and I'll probably use parentheses around this, pi times 6 squared. We should get 417 points, nope, nearest whole number, so 418. All right, the last two examples just ask you to find, and make sure you read the directions on the homework too, just find the slant height, L. So we need to use the Pythagorean theorem. You'll notice they don't tell you how long this part is, but because you know it's a square, it will be exactly half of 13, so it will be 6.5. So these are really just Pythagorean theorem problems. And we'll round to the nearest whole number. So see if you can do both of those finding L while I'm passing out your homework. How about the second one? What did we get before that one? 12 yards. If you wanted to, sometimes there will be triples that show up, so if you kind of forget those triples, you might want to go back and look at those in our previous chapters and jot them down, because sometimes they do show up and then you don't have to do Pythagorean theorem.